Okay, I'm Patrick Flanagan. I'm from ISOTX, and we're one of the early adopters of Scaleform for Unity. So I'm here to talk just a little bit about how we integrated into the game and some of the stuff that we ended up with. So just to give you kind of an introduction to ISOTX, I'll tell you a little bit about who we are. I'll show you some of our upcoming game, March of War, and talk a little bit about why we decided to use Scaleform, some of the other options that we considered, and what we ultimately ended up doing. So ISOTX is a studio based in the Netherlands. We focus mostly on strategy-based war games. We do turn-based RTS. We even have an FPS. As you can see, we try to target a wide range of audience. We have everything from younger players to older guys like myself. So we try to have something that appeals to everybody. We kind of got our start working on Command and Conquer mods, and then we slowly branched out, started working on our own games, and that's how we ended up doing this. So our most recent game, if you might have heard of, it's called Iron Grip Marauders. It recently won the 2012 Dutch Best Online Game Award. It was one of the first free-to-play games that launched on Steam when they started doing that back in 2011. And the way Marauders worked, it kind of had a split personality. It was like an online browser-based strategy game. And so we had half of it was a website that you go log into where you research upgrades and manage your armies and that kind of thing. And then when you actually play a 3D battle, it'll launch a Unity web player where you play out the actual battle that happens. So at the time, Scaleform for Unity didn't exist, so we ended up doing all of our own UI using EasyGUI, which is kind of hit and miss. It takes up a lot of programmer time. And but anyway, to give you kind of a better idea of how Marauders works, I'm going to show a quick video for that, and then that'll give you an idea of what we were building off of when we started using Scaleform. So as you saw, there was kind of like the 2D UI and then the 3D game, but it's kind of like a jarring transition to be on this website for a while, and then you go back and forth to 3D and then back to the website. So one of the goals for the new game is we wanted to integrate all of that together. So you run the game and you do everything from inside the game. You don't have to switch back and forth. We also had a lot of really cool art. We have some good artists, but the easy GUI that we put together, it wasn't really. I don't know, it didn't really show off the art that they had built. So we wanted to have much better production values. We wanted our UI to look really cool. And this time around, we wanted to work on all the different platforms, including mobile. So last time the game was just PC and Mac. This time around, we want to do iOS and Android also. So as much as possible, we wanted to have the common code base so we wouldn't have to maintain different branches for each platform, that kind of stuff. So we started working on this back in January of 2012. That was still before Scaleform came out, so we were kind of building off what we did with Marauders. We had a website and then the 3D game again, and then in July Scaleform came out. So originally when we were looking at it, we wanted to do just the HUD in Scaleform, so you'd see like the buttons and the menus and pop-ups and that kind of stuff. So we started doing that. It ended up working out pretty well. And then as we kept doing it, our artists and programmers became more familiar with it. And then we said, well, does it really make sense to have this website? Maybe we can just do everything in Scaleform. So that's kind of what we ended up doing. We have a lot of the screens that you saw that were web pages before are now re-implemented using Scaleform inside of the game. So some of the main reasons that we chose to use Scaleform, with EasyGUI, one of the problems was, it had a programmer that had to do pretty much everything. But this time, the artists and the people that aren't necessarily programmers can set up, ActionScript to move HUD elements around, and they can kind of implement some of the HUD themselves. It was a lot easier for us to find people too, because there's a huge audience of people that already know Flash. They have a big user base already, so it's kind of it's much easier to find people. And then it was sort of a natural fit for us because we're kind of a remote studio and not everybody's in the same location. So when the artists were designing the HUD, they would build a mock-up or a prototype in Flash to demonstrate how they wanted it to work, and then they would send that to us, and then a programmer would implement it. So it kind of, was a natural fit to just take that Flash movie and put it right in the game instead of then converting that to a different library. And using Scaleform lets us put, all that same code on every platform. So when we started out, we were going to convert the web pages to this, and our web pages, our web team was very used to building these responsive, dynamic web pages. We had, they were using Ajax and jQuery, so we wanted to maintain that same responsiveness and feel with the site, or with the Scaleform version. And there's about 50 screens, so we wanted a way that it could be very modular, so that people can work on the same stuff, and you're not overwriting Flash files or merge conflicts or that kind of stuff. So what we ended up going with is we have sort of a core Flash file that manages all the different sections. Like, so for page loads, it might be like a game lobby or an army screen where you see all your units, that kind of thing. So we have one Flash file that kind of manages all that, and then we have like mini pagelets, we call it, that get loaded. And so, pagelets are sort of standalone things that one guy can work on at a time, and then we integrate them all on the screen at once. So each pagelet, can through ActionScript, it can call call the game to get its own data. It can call web services. It can do pretty much anything that we need to do, and it's sort of a self-contained Flash chunk that different members of the team can work on. Another main thing that we got out of this, we decided to use CLIK, which is it's a UI library that ships with Scaleform, and it has buttons and drop downs and all that kind of thing. And but one of the main advantages of that is that it helps you set up a resolution independent system. So if you want to do something like mobile or Retina or different size screens on Android, it's it makes it a lot easier. You don't have to hard code it for a bunch of different resolutions or anything like that. So here's an example of like something you can throw together with CLIK. This is the programmer art version, so it looks pretty basic. But you can put together a screen like this in 20 minutes or something, and then you can kind of test it all out, hook it up, and then the artist can go back later and put in the real art. They can make it look fancy, all that kind of stuff. So here's another example of this is one of the screens from our website now implemented in Scaleform. This is the programmer art version. Again, it's got like the placeholder unit portraits and icons and stuff, and so the programmers can go in and set it all up and hook up the buttons, make sure everything works, and then after it works, then the artist can come back and put in the real art and sort of skin it, so to speak, and that can happen independently. So this is kind of the same screen now with the art. After the artists go through, it's it's got the real icons and the correctly sized portraits and all that stuff. So here's another screenshot from our game. We have sort of a world map area where different players and factions can fight for control of a territory. And so the world map we can implement using our 3D engine, and then we can use Flash for the buttons and the pop-ups about units and battle statuses and stuff kind of in the middle there. So it's sort of like overlaid, and you can use it as a HUD or as the complete presentation part like we were doing with the Army editor. So this is another screenshot from our game. This is the HUD using Flash, and then again the 3D game in the background. And so one of the things that's nice about this is when the artists are setting up the HUD, and they want it to look like this, they can implement all of the stuff for pressing the cards and pressing the different buttons and deploying units and everything. Most of that can be in Flash, and then they just send the game the user clicked on this unit or deployed this unit or that kind of thing. And so it makes it a lot easier for the programmers. We don't have to have programmers hook up every button and every single UI element. And so it offloads a lot of work to the artists, which they really like too, because they can iterate a lot faster on that. So this is an example of one of the Flash files that we have. This is like a targeting reticle. And so you have, basically it's a crosshair, and then these little pluses over here indicate like how effective an attack will be. There's some status bars and stuff up there. So you can kind of lay out all the layers and elements in this Flash file, and then through ActionScript you can control what's visible and what's not, and what gets colored a certain way or has a glow or different things like that. So then when you put it in the game, this is with nothing selected, sort of all the units are standing around. And then when you click on a unit, you get this ring, and you'll get like the little gear cog things over a unit. And that shows which units are in range that can be attacked. And all that stuff is implemented with Flash. So the game just says, here are the units in range. And then Flash can put the icons where they need to go. And if you click on one, it'll just send back to the game. You clicked on this unit, attack that unit, that kind of thing. And then it's also interactive. So with certain attacks, like in our game, we have area attacks where it can hit the ground and target a lot of units in a certain range. So this is what this is showing. The target things have turned red, which means if you use this attack, all those units will be hit. And so again, that's all managed through ActionScript. The game can just say, here's where you're going to attack, here's the range, and ActionScript can figure out, like, oh, these are the units that you have to do something with, and what color you do, where you position it, all that kind of thing. And then when you actually do the attack, then Flash cleans it up, all the cursors go away, and only the fiery remnants of the units are left. So how do we actually implement this in the game? So Scaleform for Unity comes with a native plugin for Mac, PC, and mobile. Autodesk gives you the source code for the C# plugin, which is all you need to integrate it in Unity. If you also want the source code, they do licensing for that too. And the way they set it up is they recommend that you have mostly Flash as the presentation layer. And so you put your heavy lifting, so to speak. You'll put that code in C# or something native. You won't necessarily do a lot of crazy ActionScript logic. We had a few differences with that. I talked a little bit about earlier how it was a lot easier to find Flash programmers since it has a big user base. And then we have separate teams doing the art for the HUD and the implementation of the game. And so it made a little bit more sense to let them do some ActionScript. So we have a little bit, but it's not performance intensive. It's mostly for UI elements, what to hide, what to show, how to color stuff, that kind of thing. There's one limitation we ran into. By default, there's a limit of 10 calls back and forth between C# and ActionScript per frame. But it's easy to change. You can just, it's in the C# code. You don't have to license the plugin for that. So we ended up, although we ended up combining those anyway. We started out with, we'd make a call for set this HUD text, set this HUD color. So we ended up with a lot of calls, and then we profiled it, and it turned out that was kind of slow. So we sort of combined it, and we have one, huge call that passes a big data structure, and from that, Flash knows, it basically does everything for one frame instead of all the little calls again. So there are a couple of things that we implemented to make it easier to integrate into our game. One of the things that the Scaleform API gives you is you can call C# from ActionScript and vice versa. But the data types that you pass are strings and floats and ints and kind of like basic types. But we wanted to pass like some crazy objects back and forth. We have a lot of web services that return structures of dictionaries and lists and all this kind of stuff, and we wanted to be able to send that back and forth to ActionScript too. Second, some of the ActionScript can trigger web service calls directly. Like, I don't know if you saw in one of the menus, we have a chat system which is implemented in Flash, and so when you type a text chat and you press send, it calls a web service to send that to the server so everybody else sees it too. So we sort of have a generic system that you can trigger web service calls from ActionScript also. And lastly, we use WebSync from Frozen Mountain for networking, like our PvP multiplayer and our chat system. It's sort of an asynchronous HTTP-based event system. And so we wanted a way for ActionScript to be able to receive WebSync events directly, so it could pop up chat notifications or achievements or that kind of stuff too. So, like I mentioned, first of all, we wanted to be able to convert data types to our custom, more detailed objects, and we wanted to use an automated approach, so we didn't have to custom code, each different web service call or each different event type. So we ended up implementing something that's it's sort of a custom converter. It uses reflection. It's sort of like a JSON or XML serializer might work. So, for example, here's some C# classes in our game. We have mission and detailed mission, and it's basically just these are structures that might be used by the game to show show what's going on or get you into a game. They're usually returned from a web service. But we want to be able to take these and pass them directly to ActionScript so that we can use them in Flash too. So what we have, this is sort of our custom conversion function. So basically this will take a C# object, and using reflection it goes through all the different properties, and it basically reconstructs that same object in ActionScript. And so like this set member, that's a Scaleform API. And so basically all the different names of properties in C# will have the corresponding name in ActionScript. And then we have another tool that basically it will auto-generate based on the C#. It'll generate the ActionScript equivalent of these classes, and then we can convert them using this function. So after we run it through our converter, then we get this on the ActionScript side. This is the ActionScript equivalent of our C# class. And so then we can pass back and forth, and when we get a mission back from our web service, we can just run it through that function and pass it directly to Flash. We don't have to do a lot of custom translation or anything. And then here's the same thing. The detailed mission class also converted into ActionScript now. So one of the other things that we ran into is that now that we have these custom objects that we're converting, we needed a way to represent null because sometimes you just don't have an object there. But Scaleform didn't have a built-in null value, so to speak. So we came up with something kind of cool for it. It's a little bit of a hack, but it definitely works. I'll show you how that works. But basically, we take advantage of the fact that in ActionScript, you can, if you create an array with more than one or more elements in it, by default, all of the values are initialized to ActionScript's undefined, which is kind of the equivalent of null. And so basically what we do is to get a null value, we call ActionScript to make a new array, and then we just return the first element. And that's our null. So we also have the C# web services that we call from ActionScript. We have the pagelet system that I kind of talked about before, and they can trigger web service calls to get data or send chats or that kind of thing. So we needed a way to do that in a generic way. So it's the same kind of thing. We have classes that automatically generate code, and you can go from ActionScript back to C# in a similar way that we did the C# to ActionScript. So, like here's an example of our ChatMessage class. So this is something that would be in ActionScript that we then want to pass to C# to send to the server or display somehow. So what we end up doing here is this is the same kind of function going backwards again, but this time we're going from ActionScript back to C#. And that way we can pass, whatever custom objects we have going back and forth. And using reflection, it's sort of automatically generated, so we don't have to, write a bunch of custom code for each different implementation that we have. And then our tool, automatically goes and generates the C# class that represents that as well. And then, so we pass data back and forth. You can also call Flash functions from ActionScript, or sorry, Flash functions from C#. So this is an example of kind of our wrapper function for this. And you can pass, whatever arguments you want, and it basically just packs all that up and sends it to ActionScript. So you can pass, complex structures if you have a lot of data to pass, or if you just have one or two things, you can, pass whatever parameters you want, and they just get passed along to the Flash as well. So one of the main things that we ran into is, performance is important for us. So we wanted to make sure things, still ran well. Scaleform comes with a Flash profiler, so you can kind of profile and see what's going on. And it works on all the platforms, so it's really nice. You can get a good idea of where your code is going slow, or what's going wrong. So when we first implemented our HUD, we noticed there was a huge frame rate drop, and it was like half, and we were trying to figure out what's going on here. So we ended up, we started profiling with the tools that they give us, and we discovered that this little cog in the HUD down here, the little circle thing, it turns out that Flash is vector-based, and this was getting converted into, you can see over there, like 21,000 triangles. So, so it's it's kind of unexpected that that little cog down there, nobody noticed, but that was half the frame rate. But that's the kind of thing that you can. It comes with really good profiling tools. You can kind of figure out where you're going wrong, and then sort of fix up your HUD based on what you've changed. This is a screenshot of the profiler that comes with the game, or with Scaleform, and you kind of profile your scripts while they're running or while they're rendering, and you see like what's what's slow or what you can improve or that kind of stuff. So now I'll show you a quick video of some of the stuff from our new game and how it compares to the original movie that I showed.